Question number 40. We need to solve this equation, and we're looking to solve it over one period. So to solve this equation, we have 10 sine t cosine t equals -4 sine t. The first step is to make the right-hand side 0. So I'm going to add 4 sine t to both sides of the equation. So I will have 10 sine t cosine t plus 4 sine t equals 0. Now I will take sine t out as a common factor. So I will have sine t 10 cosine t plus 4 equals 0. Now I have two quantities. The product is 0, which means either one of them is 0. So either sine t is equal to 0 or 10 cosine t plus 4 is equal to 0. So I'm going to solve the first equation. So sine t is equal to 0, which means t is either 0 or pi, because sine 0 is 0, sine pi is 0. Now, I'm going to solve this equation by subtracting 4 from both sides of the equation. I have 10 cosine t equals -4, and then divide by 10 both sides of the equation. I will get cosine t equals -4 over 10. Now, I'm going to plug this into my calculator, so t will be equal to the inverse cosine of -4 over 10. I'm going to find one t. Namely, this is going to be either in the first quadrant or the second quadrant. And then I will find the next one. So cosine is negative in the second quadrant, or it is negative in the third quadrant. So the answer that I'm going to get is going to be in the second quadrant, and then I will find the answer in the third quadrant. So let me just plug that into my calculator. So I got t equals 1.9823, rounded to 4 decimals. So it is in the second quadrant. Now I'm going to find the other one. Because the inverse cosine is going to give me a unique answer, I have to find the other answer manually. So this t that I found, the first angle is approximately here, which means all of this is measured t that I found, which is 1.9823. Now, I want to find the other angle in the third quadrant, which is going to be this angle right here, meaning that if I take 2 pi and I subtract t from it, which is the same as this amount, so I'm going to say that just t1 here. So if I take 2 pi and subtract t1 from that, which is the same amount, but in the negative direction, I will get the angle in the third quadrant. So I'm going to say 2 pi minus the answer, and I will get 4.3009. So all of the answers are 0, pi, 1.9823, and 4.3009, and all of these are rounded to 4 decimals. So that is question number 40. Question number 41, I have 2 cosine square x plus cosine x minus 1 equals 0, and I want to solve over one period. Now, I'm going to factor this into 2. I have 2 cosine x, and I have cosine x. Now, I'm going to look for two numbers. The product is -1. that is 1 and -1, but I have to, so if I try this, if I try -1 and +1, and then multiply the outers, I'm not going to get the middle number, which means I should reverse the signs. Now, 2 cosine minus sine is cosine, so I got the right answer here. Equals 0. I have two terms or two quantities. The product is 0. That means either the first one is 0 or the second one is 0. So either 2 cosine x minus 1 equals 0 or cosine x plus 1 equals 0. I'm going to solve each one of these individually. So now I will add 1 to both sides of the equation. The first equation to solve it, I will have 2 cosine x equals 1. Divide by 2, I will get cosine x equals to 1/2. Now looking at the unit circle, I know that cosine is positive in the first quadrant and in the fourth quadrant. First quadrant and the fourth quadrant. The angle that has a cosine of 1/2 is pi over 3 in the first quadrant. And then in the fourth quadrant, it is going to be 5 pi over 3. So those are the two answers from the first part. From the second part, I'm going to subtract 1 from both sides of the equation. I have cosine x equals -1. Now, I know that x, or the angle that has a cosine of -1 is pi. So answers are going to be pi over 3, 5 pi over 3, and pi for this question. Number 42. Question number 42. We need to solve 2 cosine, solve it here, square x plus 7 cosine x plus 5 equals 0. Again, we're going to factor 2 cosine x and cosine x. 5 is 5 and 1. So I'm going to put the 5 here and the 1 here. 5 cosine plus 2 cosine is 7 cosine. So my factoring is correct. Now I will proceed by putting this equal to 0, and then either 2 cosine x plus 5 equals 0 or cosine x plus 1 equals 0. Now I'm going to solve the second one. I'm going to solve the second one first. Subtract 1 from both sides of the equation. Cosine x equals -1. X is equal to pi. The first one, if I solve that one, it's going to be -5 from both sides equation. 2 cosine x equals -5. Divide by 2. Cosine x equals -5 over 2. I'm going to plug that into the calculator in radians mode. When you plug that into your calculator, you're going to get an error. The reason for that is because cosine x here is less than -1. Namely, it is -2.5, which is impossible. So this side of the equation not going to give me any answers because that is impossible, and the only answer I have is x is equal to pi. So now to answer the question basically says here, find all of the solutions. It doesn't give you a specific period. So all of the solutions, pi plus multiples of cycles. So we know that we're going to get the same answer each time we add a full cycle to that, or full circle to that, or full revolution. So if we repeat the process, we can always say the answer is pi, the solution, plus multiple of periods, which is 2k pi, such that k is an integer. So that is the solution for question number 42. Number 43. So question number 43, we have 8 sine 2w plus 9 cosine w equals 0. First, we need to write the double angle as a single angle. So we know that sine 2 theta is equal to 2 sine theta cosine theta, 8 times sine 2w is 2 sine w cosine w plus 9 cosine w equals 0. This is equal to 16 sine w cosine w plus 9 cosine w equals 0. Now I'm gonna take cosine out as a common factor, so I will get cosine w. The remainder is 16 sine w plus 9 equals 0. So I have two quantities. Their product is 0. That means either one of them is 0. So this is going to be either cosine w is equal to 0 or 16 sine w plus 9 equals 0. I'm going to solve the first one here. We know that w, the angle such that cosine, that angle is equal to 0, is going to be happening at pi over 2 and 3 pi over 2. Pi over 2 and 3 pi over 2. And then I will solve the next one by subtracting 9 from both sides of the equation. I would get 16 sine w equals -9. Now divide by 16 both sides of the equation. I will get sine w equals -9 over 16. Now w is the inverse sine of -9 over 16. I know that sine is negative in the third quadrant or fourth quadrant. Now I'm gonna plug this into my calculator in radians mode. You're gonna get, you will get w is approximately -0.5974. We need the positive angle here. We don't want the negative angle. So to find the coterminal angle, I'm gonna add 2 pi to this. So if you add 2 pi, you're gonna get the first angle is approximately 5.68. Let me just 5.6878, rounded to 4 decimals. So this is the first solution. It's in the fourth quadrant. I'm gonna try to find the third quadrant. So here is the fourth quadrant. It's approximately here. This is the fourth quadrant, which basically this angle we computed, and that was -0.5974. So in order to find the angle in the third quadrant, which is this angle right here, I could basically say, so the other angle, the positive angle that we found is basically, we did this, not all of that here. So here's the first angle, okay. So that is basically the negative angle, and then to find the positive angle, what we did is we went backwards. So we did the positive one. this way. So 2 pi minus that much will give us the coterminal angle. Now, to find the other angle in the third quadrant, we're going to say this is equivalent to pi, this is pi, plus that much, which is this angle, but it's positive angle. So I'm going to say the other W is approximately pi plus 0.5974. So if I do pi plus 0.5974, I will get W is approximately 3.73899. So the solutions for this equation are pi over 2, 3 pi over 2, and then 5.6878, and then the last one is W is equal to 3.73899. All of these are round numbers. And then question number 44. Cosine 2 theta, notice how I have 2 theta here, double the angle. I'm going to make it single angle. Cosine 2x is equal to, and I'm going to try to keep it cosine all. So I know that cosine double angle is equal to 2 cosine square x minus 1. So that's what I'm going to do here. So cosine square, 2 cosine square x minus 1 minus cosine x. I'm going to rearrange the terms. So this is going to become 2 cosine square x minus cosine x minus 1 equals 0. I will factor. So I have 2 cosine x and I have cosine x. I have negative 1, positive 1. Let me multiply. Negative 2 cosine plus cosine is negative cosine, so that is correct. Now I'm going to say either 2 cosine x plus 1 equals 0 or cosine x minus 1 equals 0. I'm going to solve the first one by subtracting 1 from both sides of the equation. So 2 cosine x equals negative 1. Cosine x equals negative 1 over 2 after you divide by 2 both sides of the equation. So now we're looking for all of the angles that have a cosine of negative 1/2. I know cosine is negative in the second quadrant and in the third quadrant. So that is where I'm going to look for the angles. That is 2 pi over 3 and 4 pi over 3. To solve the next equation, I'm going to add 1 to both sides of the equation. I have cosine x equals to 1, and that happens when x is equal to 0. So my solutions are 0, 2 pi over 3, 4 pi over 3. The next question. I have the right triangle below. We need to find the measure of the angle, in this case, this one. And we need to round our answer to 1 decimal. So I know relevant to that angle, let me just name that angle alpha maybe. Okay, I have the opposite and the hypotenuse. So I can use sine alpha, opposite over hypotenuse, and then alpha is equal to the inverse sine of 2 over 6. And I need to measure this in degrees, so make sure you change your calculator setting to degrees, and then inverse sine of 2 over 6 is equal to 19.5 degrees. And number 46, we want to evaluate the following expression. So we need to find inverse sine of negative 28 pi over 5. We know that the inverse sine and sine cancel each other, and the answer here will be negative 28 pi over 5. But remember that the range for the inverse sine is between negative pi over 2 and pi over 2. This doesn't happen to be in that range, so to make it go to that range, I'm going to keep adding one full cycle. So this is going to be negative 28 pi over 5 plus 10 pi over 5. And that is going to give me negative 18 pi over 5. Again, I'm going to add 2 pi one more time. So this is going to be negative 18 pi over 5 plus 10 pi over 5, which is negative 8 pi over 5. I will add 2 pi one more time. So this is going to become negative 8 pi over 5 plus 10 pi over 5, which is going to give me it's going to give me 2 pi over 5. 2 pi over 5 is between negative pi over 2 and pi over 2. So that is the final solution here. Question number 47. I have inverse sine of cosine pi over 4. I know that cosine pi over 4 is square root of 2 over 2, so I need to find inverse sine of square root of 2 over 2. So in other words, I'm looking for the angle such that sine that angle is equal to square root of 2 over 2. So the first angle that I'm looking at is pi over 4. Pi over 4 is the first angle that is in the first quadrant, and that angle happens to be in the range of inverse sine, which is from negative pi over 2, pi over 2. So we stop right there, and that is our answer. Last question. I need to compute inverse sine of 5 of cosine 5 pi over 3. We know that cosine 5 pi over 3 is equal to 1/2. So that is inverse sine of 1/2, because cosine 5 pi over 3 is equal to 1/2. So we're technically looking for an angle such that sine that angle is equal to 1/2. We know that sine is positive in the first quadrant and second quadrant, but the inverse sine range is from negative pi over 2 and pi over 2, so we're going to stick to the first quadrant only. Theta in the first quadrant that has a sine of equal to 1/2 is pi over 6. So theta is equal to pi over 6, and that is going to be our answer.